There's lots of questions that come up when we deal with exponential models. One of them is about continuously compounded interest, normally related to money. So let's look at two different styles of interest and how they might be compounded. On the left, you have the traditional kind of fixed number of time periods where maybe every year or every quarter, your money is, well, multiplied, right? So you gain more money every 3 months, every 6 months, or every year. On the right-hand side, we have this continuously compounded interest where your money is compounding kind of as fast as it possibly can. We have a number of different variables going on here. They all mean pretty much the same thing. The A in the first one is the amount that you're going to have after a certain number of time. On the left, it's the amount you're going to have after a certain amount of time, so the same as there. This A right here, sometimes lowercase, is the initial investment. Over here, we call it a P for principal. I'm not really sure that there's a significant difference there. It's the same concept. Inside here, the base of our exponent is 1 plus whatever our growth rate is. So imagine we had a 4% growth. This would be 1 plus 0.04 or 1.04. Over here, this is Euler's constant. This is just a number. It's an irrational number, so we use a symbol for that. Your calculator has that. It's somewhere like 2.7 something, something, something. So your calculator has access to Euler's constant. And then the exponent here is the t, which is the number of time intervals or time periods, often measured in years, but can be different. Up here we have two things that multiply together to form your exponent. We have the rate, which you might have seen over here previously. You have the rate and you have time, right? So there's a lot of similarities between these, but they're built differently. So let's take a look at one style of question. Let's do it two different ways, and that'll be that. So here is a typical question you'd see in any textbook. Calculate the amount of money in a bank account that begins with $5,000, that grows at 4% annual interest, and they want you to do it two different ways. They want you to compound it continuously, and they want you to compound it annually for 7 years. So let's fill in some basics here. So we're trying to figure this thing out. It's a $5,000 initial investment at 4%, so 1.04 for 7 years. So the one on the left is very simply just a calculator task, and you're going to find that the one on the right is pretty much the same thing. The amount of money we invest initially is $5,000. We have Euler's constant E. We have the interest rate of 0.04, and that multiplies by time of 7 years. So if I can find a way to stick all this into my calculator while you can see it, let's see, 5,000, 1.04, and 7. So we have 5,000 times 1.04 to the power of 7. And if we've done this correctly, we should be getting this number. So I'm going to write this down, 65.79, 66. 65.79 and 66 cents. If I remember that correctly, 65.79, 66. Let's check it out. Yep, I think we have it. Now on the opposite side, let's go ahead and do the continuously compounded. I would expect this to be quite a bit higher so that it's easier for me to remember. I'm going to do one piece of math in my head. I'm going to go ahead and do the exponent. So 4 times 7 is 28 with 2 decimals, so 0.28. So now I'm going to take 5,000 e to the 0.28. Now the way this works, this is key. The thing that's being taken to the exponent is the e, is Euler's constant. So I have to do that part first, and then I'm going to multiply by 5,000. That's kind of key. So that would be a common spot for a mistake as well. So e to the 0.28 times 5,000. So over here on my calculator, so Euler's constant to the 0.28 times 5,000, and I get 66, 15, 66. 66, 15, 66, 66, 15, 66. So what you're going to find is that the continuously compounded interest is more money than the fixed number of time periods. It's not huge, but that is another $500 or so. So it is worth it to get continuously compounded interest if you can find a bank that will give it to you.